Hello guys, welcome to our new unit. Today we're going to talk about solving one-step equations by adding, subtracting, multiplying, or dividing. This should be a bit of review for you. So bring it on. If you need some extra help, you can look in 2.1 and 2.2 in your book. First idea I want to talk about with you is what is an inverse operation? An inverse operation is just something that you do to reverse or undo what's been done to a variable. So if I want to undo addition, what do? Right? I subtract. If I want to undo multiplication, what do? I divide. If I want to undo subtraction, what should I do? I should add. If I want to undo division, the inverse operation for division, I would multiply. So the inverse operation is multiplication. I want to talk to you about equations. This is an example of an equation. You can tell it's an equation because there's an equal sign. There you go. And the beautiful thing about equations is that they are in balance. They always balance out. Whatever's on the left side always has the same value as what's on the right side. So you can see since there's an equal sign here, that tells me that the value of x plus 4 is the same as the value of 10, and they balance out. And if I double what's on this side, I've got to double what's on that side in order for my scale to stay in balance. If I take away 35 from this side, I've got to take away 35 from that side in order for this scale to stay in balance. Let's do the doubling thing. If I double what's on this side, I've got to double what's on that side in order for the scale to stay in balance. Okay. Let's go ahead and try to solve this equation. So right now what I'm trying to do, my goal here is to isolate x. I want to figure out the one value of x that if I can substitute it right here will make this equation true. Now I know you can do this in your head. That's okay. We're going to learn how to do it the algebraic way. So in order to figure out what the one value of x is that'll make this equation true, I have to do something called isolate the variable. I have to isolate my variable x, and isolate means I need to get it all by itself. So let's look at this side of the equation. Is x all by itself? Nope, it's not by itself. Someone went ahead and added 4 to it. So I need to do the inverse operation. I need to get rid of that 4. What is the inverse operation to adding 4? Subtracting 4. So let's subtract 4 from this side so that and if we do it to one side, we have to do it to the other side to keep this scale in balance. So I bring down my x. 4 plus negative 4 is 0. And 10 minus 4, or 10 plus negative 4, is 6. So now I have x plus 0 equals 6. And the reason I performed this inverse operation here, the reason that I subtracted 4 was because that's exactly what I wanted to do. I wanted to get to 0. Because if I can get to 0 over here, then really x is kind of all by itself. So that I did exactly what I wanted to do. So let me erase that so I can keep that nice and straight. So x plus 0 is equal to x. And so x is equal to 6. Now I'm going to check to make sure that's true. The way I check is I take my original equation, x plus 4 equals 10, and I substitute 6 for x. So now I have 6 plus 4 equals 10. Does it work out? Ah, that's true. 10 is equal to 10. Yes, I found the answer. So the one value that makes this equation true is when x is equal to 6. Okay, let's try this one. Let's look at this equation, and my question is x isolated? No, it's not. So what is happening to x right here? Well, 9 is added to it, right? What's the inverse operation of adding 9? I'm going to subtract 9. Okay, so let's do it to both sides. So I'm going to subtract 9. I'm going to subtract 9. Draw that line to keep things in balance. Let's see what I end up with. I end up with 0 plus x is equal to, see, negative 3 plus negative 9 is negative 12. So I end up with x is equal to negative 12. Okay, so let's check my answer. I did it to both sides. So I have 9 plus x equals negative 3. And I said that x was negative 12. So 9 plus negative 12 equals negative 3. So see, what is 9 plus negative 12? Oh, look, how about that? It's negative 3. Is negative 3 equal to negative 3? It's a negative there. Yes, it is. Great. Checks out. Okay. So my answer is x equals negative 12. Okay, so I'm looking at x. Minus 5 equals 0. Is x isolated? Nope, it's not by itself on one side of the equal sign, so I've got to actually solve. So what's happening to x? We're subtracting 5 from it, right? Okay, what is the inverse operation? Oh, let's add 5 to it. So let's add 5 to it. If I do it to one side, got to do it to the other. And I end up with x plus 0 is equal to 5. That means that x is equal to 5. Let's check our answers. So I have if x minus 5 is equal to 0. Let's put 5 in for x. I have 5 minus 5 equals 0. Let's do 5 minus 5. 0 equals 0. Oh, yes, it does. Good job. It's checked. So my answer is x equals 5. That is the solution to this equation. 5 is the one value that I can stick in that equation that'll make it true. Any other number doesn't work. Okay, what's happening to x? First of all, I'm subtracting negative 6 from it, right? But that's a bunch of negatives. I'm going to change that guy. It's ugly. Okay. So what's happening to x? Let's see. I am adding 6 to it. Okay. So what's the inverse operation? I'm going to subtract 6 from it. So let's subtract 6 from this side, which means I've got to subtract 6 from this side. That gives me x plus 0 is equal to 1. X is equal to 1. Let's see if that works out. So 1 minus negative 6 should give me 7. I leave change that. I get 7 equals 7. Oh, yes, it does. And it's checked, so that my answer is x equals 1. What is the only number that I can put in that equation that will make it true? Okay. Now you try the next few ones. Okay. Now we're going to solve equations by multiplying and dividing. So I'm going to look at my x, and is my x isolated all by itself? Nope, it's not. What's happening to it? Well, it's being multiplied by 3. What's the inverse operation to multiplication? It's division. So I'm going to divide by 3. So let's do it to that. If I do it to one side, got to do it to the other. So let's see, what do I get? I get, so these divide out, and I end up with x is equal to 15 divided by 3 is 5. I mean, that's why I'm dividing by 3. I'm dividing by 3, so right here, these values will divide out, and I'll get x all by itself. It's kind of why I'm doing what I'm doing. So I end up with x equals 5. Let's check it and see if it's true. So I have 3x is equal to 15. So I said x was 5. So you're telling me that 3 times 5 is equal to 15. Do this math here. I end up with 15 is equal to 15. Oh, yes, it is. Oh, yes, it is. Yay. And so my answer is x equals 5. All right. Is x by itself here? Nope. What's happening to it? Oh, it's being divided by 7. What is the inverse operation to division? Multiplication. So I'll want to multiply by 7. Okay, so let's do that to both sides. So I'm going to take this whole thing. I'm going to multiply it by 7. You can make it 7 over 1 if that makes you happy. I'm going to take this whole thing and I'm going to multiply it by 7. Let's see. So these 7s are going to divide out, and I'm going to end up with x, or x over 1, is equal to negative 42. Okay. So let me check my answer. So someone's telling me that negative 42 divided by 7 is equal to negative 6. Let me see. Let me do this math on the left side. So I end up with negative 6 is equal to negative 6. Oh, yes, it is. Checks out. So my answer is x is equal to negative 42. Negative 42 is the only number that I can replace x with and make that equation true. Okay, now what's happening to x here? Oh, it's being multiplied by negative 4. Okay, so now what is the inverse operation of multiplication? Oh, division. So I'm going to divide by negative 4. Let's divide this side by negative 4. Let's divide that side by negative 4. And let me see, what's my new thing? I end up with, my negative 4's divide out. And I end up with x is equal to negative 11. Let me check my answer. That seems kind of hokey there. Let's see. Negative 4 times negative 11 equals 44. Let's see. Negative 4 times negative 11 is 44. Does 44 equal 44? Oh, yes, it does. Oh, yes, it does. So my answer is x is equal to negative 11. You try? And you try. Oops, no, that was it. That was all you had to do? Just that one? Well, you guys are lucky. You're such a softie. Okay, I'll see you in class.